This is Team 20 and team members are Alyssa, Brian, Katie, Will from left to right. Alyssa is proficient at teamwork. Brian contributed on Excel work. Katie is responsible for Word documenting, and Will is good at programming. Our project name is Save the Purdue. The client, the Campus Safety Committee, requires a proposed solution to harmoniously integrate all types of public traffic at Purdue University's campus in order to decrease mobility-related accidents. Purdue University traffic and parking regulations seems it necessary and desirable to make and enforce these regulations for the safety and welfare of users such as students, staff members, and visitors, the proper use and protection of the property of the university, and the efficient operation of the university. The final solution needs to meet criteria of energy efficiency, affordability, and decreasing amount of accident occurs. Also, the final solution needs to meet constraints of easy installation and minimizing distractions for passengers. The problem of reducing the amount of mobility-related accidents is important in society's perspective because students have rights to walk in safe campus. It is also important in economical perspective since when the accident occurs, students are responsible for paying fees for recovering, which would result into students' financial issues. We first started our brainstorming exploring prior art. For example, the pedestrian countdown signals have been widely used due to its functionality, but it has limitation it hard to be installed in bike intersection. We came out with about 20 solutions after brainstorming process, and we narrow it down to 3 solutions, which are speed checker, speed bumper, and bike lane warning lights. Speed bumper is simply put the bumper on the road to minimize accident. Speed checker is checking the speed of the bicycle that goes through specific range and indicate light sign when it goes over speed limit. To decide the best solution, we used survey to earn the feedback from stakeholders. To find the best prototype using mathematical concept, we utilized weighted decision metrics to rate each of our prototypes. Bike lane warning light achieved score of 5 for the minimizing distraction also. Overall bike lane warning light earned score of 235, which is the highest score among 3 of possible solutions. The solution begins with a simple painted, white pedestrian crosswalk on the bike lane. This is intended to direct pedestrians to minimize the span of areas they cross, causing less confusion on the entirety of the bike lane. The second part of our design includes the installation of a string of green LED lights, protected by a thin and clear plastic cover, along each side of the painted crosswalk. The LED lights will be connected to a Grove Ultrasonic Ranger. The Grove Ultrasonic Ranger measures the range of an oncoming object. The sensor will be programmed to change the green LED lights to red when an object is coming within 10 feet of the crosswalk in either direction. We are going to use solar panel to reduce energy consumption. Similar to how a pedestrian walk signal functions at road crosswalks spark movement in a pedestrian, our team believes that the change in light from green to red will cause the pedestrian to hesitate to cross the bike lane and look up for the oncoming traffic. We propose that the first bike lane warning light system is placed in front of the Wilmette Active Learning Center where, based on surveys, students have specifically pointed out that location as an area of high concern. We believe our solution satisfies all criteria and constraints. First, the bike lane warning lights are energy efficient because we chose an LED system and to power the system with solar energy. The LED lights produce a high output of light while minimizing energy consumed. Secondly, the bike lane warning lights will decrease the amount of accidents that occur on campus. The crosswalk will encourage pedestrians to cross in one area and the LED lights will warn them when it is unsafe to cross. Based on survey results, 94.45% of students would agree that this would reduce accidents on campus. Thirdly, our solution does not go over budget, which should be less than budget limit of $471,000. The setup of our system requires only 1 small solar panel, 2 Grove ultrasonic sensors, white paint, and 2 strips of LED lights, and the total cost would be in $5,722 range, which meets our budget. The solution does not require intense construction nor new facilities to be implemented. Lastly, the warning lights will fit into campus without major disruption. The system takes up minimum space, which is about 5 meters circumflex 3 volume, as the solar panel is the only part of the system that will need to be placed strategically to avoid disruption of campus. 100 of surveyors agreed that the solution will be beneficial to Purdue's campus. One limitation is the lights we are using require high maintenance fees as the environment could damage aspects of the lights. Also, the lights are not energy efficient as they must remain on all day. However, we can manage this limitation by collecting data of peak travel times to find when we could turn the lights off to save energy. One trade-off made was trading lower construction costs for more awareness on the paths. We had the idea to put a warning light on a sign, but we felt that this was not enough to stop distracted pedestrians. A final trade-off made in this design was longer construction time in order to install the lights. In turn, the design will be safer than other ideas with lower construction time. This prototype and design should significantly decrease pedestrian and bike accidents on campus, while staying under budget and not deteriorating from campus in any significant way.